So you can see my final output is nothing but the difference between VA-O and VB-O. And this difference, when you take before the diodes, we can call it as VAO and VBO, and that was nothing but a AM signal. The difference between them represents the AM signal. So when it passes through the envelope detector part, what we will get at the output side will be nothing but my modulating signal. So to summarize everything, from FM to PM conversion takes place with the help of this very simple principle, which says that tune both the primary and secondary to carrier frequency, add the primary voltage to the upper half secondary voltage as well as lower half secondary voltage. This will give you AM signal, and pass the AM signal through two envelope detector circuits and get the final output across the two ends, A dash and B dash, which will give you the difference between voltages at A dash O and B dash O, and that will represent nothing but my modulating signal. So we get modulating signal at the output. Now, what is the advantage of doing all this? Why are we not using the slope of the characteristic of tuned circuit to convert FM signal to AM signal, something that we did in the previous two demodulators? We are not doing that just to avoid the non-linearity of the characteristics. In this case, the conversion from FM to AM is obtained through totally a different principle, which is based on this phasor diagrams, and nowhere the non-linearity comes into picture. So the conversion from FM to AM is more linear, and hence final modulating signal that we obtain will be much more similar to the original signal compared to what we get in the first two demodulators. In spite of improvement in the linearity, there is one problem in Foster-Seeley discriminator, that there is no amplitude limiting. There's something called as amplitude limiting. What is amplitude limiting? We all know that FM signal has constant amplitude. What changes is the frequency of the signal, but the amplitude never changes. If suddenly there is change in amplitude, let's say for any reason, then this change in amplitude will be mainly due to the presence of noise. So now, if there are any change in amplitudes, then that change in amplitude will disturb this conversion from FM to AM and will generate distortion at the output side. And for this reason, my circuit should have that inherent capability of rejecting these changes in amplitudes which occur in FM signal, because they are only due to the noise. Foster-Seeley discriminator cannot do so. It cannot identify the changes in the amplitude and accordingly remove its effect. And because of this, even when we have achieved the advantage in terms of improved linearity of FM to AM conversion, there is the drawback is that there is no amplitude limitation provided by the circuit. And just to obtain amplitude limitation, that one important feature, we will go to the fourth demodulator that we use for FM demodulation, which is called ratio detector.